Okay, let's do some homework problems from section 6.2. So first problem, problem number 1. What requirements are necessary for a normal probability distribution to be a standard normal probability distribution? Well, we said that for standard normal distribution, since it's normal distribution, the density curve is bell-shaped, and since it's standard normal, that assumes that the mean, the expected value, is 0, and that the standard deviation is 1, and also the variance, which is the square of the standard deviation, is also 1, because 1 squared is 1. Okay, so mean mu is 0 and standard deviation sigma is 1, so that seems to be answer C. Then let's do problem number 2. The waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 9 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 1.25. So we have uniform distribution on 0, 9. So let me sketch the graph. 0, 9, and the question is, what's the probability that the waiting time is of randomly selected passenger is greater than 1.25? So 1.25, let's say somewhere here, and the question is, so all possibilities for waiting are in this interval from 0 to 9. But now the question is, what's the probability that the waiting time will fall into this interval between 1.25 and 9? Well, since this is uniform distribution, we said that in that case the probability of a uniform random variable falling into a certain interval is equal to the ratio of the length of that interval and the length of the entire sample space, the interval which serves as a sample space. So the length of this interval from 1.25 to 9 can simply be found by taking the difference, 9 minus 1.25, divided by the length of the entire interval from 0 to 9, which is 9. In general, you would find it as upper bound minus lower bound, but that's, of course, in this case, it's obviously 9. The denominator is 9. The numerator is obviously 7.75. Okay, so 7.75 divided by 9. That number, that number is 0.8611. I copy it and paste it here, so 0.8611. Simplify your answer, round to 3 decimal places. So if we round this, since the 4th decimal place is 1, we don't change the 3rd decimal place, so we just delete the 2nd one. And fantastic. Okay, let's do problem 5. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with mean 0 and standard deviation 1. So again, standard normal distribution. Find the probability that a given score is less than negative 1.24 and draw a sketch of the region. So probability that the score will be lower than negative 1.24. So here is negative 1.24 number, and we are looking for the probability of getting a number below it. So we are looking for the region above the interval from minus infinity to negative 1.24. So that corresponds to this graph. Okay, so among all these graphs, this one A is correct. The second one is probability of getting a number between negative 1.24 and 124. Of course, that's not what we are looking for. Another, this one is probability of getting a number higher than negative 1.24. You see the difference between A and B. A is getting a number below this critical value, and this one is getting a number above. So the answer is graph A. And the probability, so round to 4 decimal places as needed. So what is the probability of this? Well, we can use Excel to find the cumulative probability up to negative 1.24. We use function norm.dist. So you need to start with equals to tell Excel that's a formula. Norm.dist x is the z-score, in our case negative 1.24. The mean of the normal distribution is 0 because we deal with standard normal distribution, and the standard deviation is 1, again because it's a standard normal distribution. And the last argument, cumulative, it should have value true or false, or 1 or 0, so true for 1, 0 for false. If you want cumulative. So the other one is probability mass function, so that's actually, we are not interested in that. So we need 1. Okay, so 1 means yes, cumulative, and when we hit enter, this is what we get. Control copy, and then go to this box, and it says round to 4 decimal places. So where is the 4 decimal place? So 4 is in the 4th decimal place, 8 is in the 5th one, so we update 4 into 5. Oops, 5, and delete the right from there. So that's the value. Let's do problem 7. Assume the readings on thermometers are normally distributed with a mean 0 and standard deviation 1. Find the probability that a randomly selected thermometer reads greater than 1.61 and draw a sketch of the region. So greater than 1.61. So these two graphs, A and C, have 1.61 as a distinguished point. But it is this one that covers the region over the interval above 1 point. Over the interval from 161 and above. So this is the answer, C. And what's the probability? Well, to find this probability, what you can do is you can either use Excel, norm.dist, or you can use one of these, but the Z table. In whether you use Excel or these Z tables, in each case you are computing cumulative probability from minus infinity up to your z-score. So that's not directly what you need. You need from 1.61 and further. So, but this this area, because the bell below the bell-shaped region, the area, total area is 1. This area here is actually 1 minus this non-shaded area. Okay, and the non-shaded area is the cumulative probability of getting a number from minus infinity up to 1.61. all right, so what we are going to do is we can make use of the cumulative distribution, and so there are 2 pages of the table. I'm going to use this one, but let me show the first page. Negative z-scores, so that's a cumulative probability for z-scores up to a negative numbers, up to negative numbers, and the other one is cumulative distribution for z-scores positive. Okay, so in this case, since we have 1.61, that's a positive, so we are going to use this second table. So 1.61, so that's you start with a row which starts with 1.6. all right, so in that row the z-scores are 1.6 and then some other digit, and then some digit on the second decimal place. So 1.6, and since we need 1.61, you look for the column 0.01. So it's like you are adding 1.60 and you add 0.01, so you get 1.61. So in the cross section, in the where these row 1.6 and column 0.01, when they cross, that's where the value of the cumulative probability for getting a number from minus infinity up to 1.61. So this number is 0.9463. 0.9463, okay. 0.9463, and it says round to 4 decimal places, so it's okay, but that's a cumulative distribution up to 1.61, but we need actually the complement of that, so we need 1 minus that. So we don't need this number, we need the 1 minus this number, and it's going to be 0.0537. 0.0537. That's the number. The alternative way would be to use Excel. So let me do it here. Equals, so we need 1 minus the cumulative distribution up to 1.61. So 1.61. So you see we have 1 minus this 1.61, comma 0, comma 1, comma cumulative, yes, so that means 1. So, and as you can see, when you round to the so it's when you round, it's a 0.0537, so that's 0.0537 as we had here. Okay, number 8. Assume the thermometer readings are normally distributed with a mean 0 and standard deviation 1. Thermometer is randomly selected and tested. For the case below, draw a sketch and find the probability of the reading. So the given values are in Celsius degrees. Okay, so what's the probability of getting a number between 0.75 and 2? So we have a standard normal distribution, and the question is, so the reading is normally distributed, standard normal, and what's the probability that the reading will fall between 0.75 and 2? So what region corresponds to this situation? So between 75, so above 0.75 and below 2, so that's this one. Okay, so as you can see, from 0.07 from 0.75 to 2, so we this area is equal to the probability of getting a number between this number and this number. So for getting a number in that interval. Okay, so we say C, and the second part is what is the probability of getting a reading between 0.7 and 2. So let us find that probability. So what you can do is to think in this way. So here is our bell-shaped curve, and we need the area between 0.75 and 2. So let's say here is 0.75 and here is 2. I'm sorry, not negative 0.75. I'm sorry. So let's say somewhere here, 0.75 up to 2. Okay, so what we need is this red shaded area. The way we can compute it is we can look for the cumulative distribution, the cumulative probability up to value 2. Okay, so I don't know, maybe I should use purple. So the cumulative distribution up to 2, cumulative probability up to 2, so that's blue plus red area minus the blue area, which is the cumulative probability from minus infinity up to 0.75. So that's what we are going to do. So we need cumulative probability for z-score 2 and cumulative probability for z-score 0.75. Well, we can use the table. So for positive scores, value 2, so that means 2.00. So 2.0, and you see the column 0.00, so 2.0, so that's 0.9772. So we have here the probability is 0.9772. So that's blue plus red, and then we need to subtract the blue area. Okay, and again we'll look for z-scores, and now 0.75. So 0.75, here is 0.70, and we need to go to the column 0.5, so 0.05, so here is column 0.05. So we have 0.75, so that number is 0.7734. 0.7734, and we need to subtract these two numbers, so that's 0.2038 if I'm not mistaken. .2038, and it says round to the 4 decimal places, so here is 4 decimal places, so we can try and can answer, and that's correct. Alternative way would be what? Alternative way would be using norm dist function in Excel. So let me use here equals norm dot dist of 2, right, 2.0 or just 2. The mean is 0, standard deviation is 1, cumulative yes, minus norm dist, what is it, 0.75, comma 0, comma 1, so mean 0, standard deviation 1, and cumulative yes. So 0.203877, so that's actually more precise. The Excel is more precise than the table, but you see it's so the software would probably tolerate if you write 0.2039 instead of 0.2038, which we have here. Okay, next problem, number 10. Assume the thermometer readings are normally distributed with mean 0 standard deviation 1. So again, the same kind of problem. A thermometer is randomly selected and tested. For the case below, draw a sketch and find the probability of the reading. Okay, so we need the probability of getting getting a reading between negative 1.42 and 1.86. So that's apparently this one. So we answer excellent. Okay, and now the probability. What's the probability? Well, again, we can use z-scores. So 1.86. We can use the table for z-scores. 1.86. So here is 1.80 and 6. Here is the count. So 0.9686. So maybe I should again draw a graph. So the picture goes like this. Again, bell-shaped curve. And we have from negative 1.42 to 186. Negative 1.42 up to 1.86. So we need this area. To find this area, we can find blue plus red area, which is the cumulative probability of getting a number up to 1.86. So that's this probability minus the probability of getting a number up to negative 1.48. So we can use the table. So 1.86. So we said 1.86. So it is 0.9686. So probability is 0.9686, right? 0.9686, and then minus the cumulative probability for getting a number up to negative 142, since that's a number, that number is negative. So we need the page 1. So negative 1.42. So the reading is similar as for the positive one. So negative 1.42. Okay, and 42. So this is 0 in the second decimal place, 1, and this is 2. So this is 0.02 column. So we read 0.0778 minus 0.0778. So when we subtract, we get we get 0.8908. So 0.8908. 0.8908. Check answer, yes. Alternatively, you could again use Excel, so equals norm this, or 1.86 mean 0 standard deviation 1, yes, cumulative, minus norm this of negative 1.42011. So this is 0.890. When you round to the 4 decimal, that's 8, just like we got here. Okay, all right. Next problem. Problem 11. Find the indicated area under the curve of the standard normal distribution, then convert it to percentage and fill in the blank. Okay, so actually I will do similar exercise. So between negative 1.9 and 1.9, so we can again sketch the graph of the bell-shaped curve, and we have from negative 1.9 to 1.9. So find this probability and express it in percentages. So again, what you can do is cumulative probability from minus infinity up to 1.9. So that's this blue plus red, and then minus the blue area, which is the cumulative probability of getting a number from minus infinity up to negative 1.9. Okay, so you can use again tables. So 1.9, so 1.9, so just 1.90, so that's 0.9713. What did I say? 0.9713? 0.9713, yes. Minus the probability, or in cumulative probability up to negative 1.9. So negative 1.9 is this one. Negative 1.90. So that's again first column, 0.0287. So minus 0.0287. So it's this value, 0.9426. 0.9426, but since we need in percentages, we better multiply by 100, so that's 94.26. okay, round to 2 decimal places, and that's what we get. Alternatively, you could use Excel, so let me write it here. So norm.dist of 1.9019 minus norm.dist of negative 1.90110, and 1 because the mean is 0, the standard deviation is 1, and 1, the last one is cumulative. So when you round, so if you also want to multiply by 100, let's see here, equals the one on the left times 100 times 100, and if you want to round to the 2 decimal places, so you can click on this cell or this column, right hand click, format cells, number, and then decimal places, round to the second decimal place, and you see 94.26, which is exactly what we got. Okay, and the last problem is, assume that the readings on the thermometer are normally distributed with a mean 0 and standard deviation 1. Assume 2.2% of the thermometers are rejected because they have readings too high, and another 2.2% are rejected because their reading is too low. Draw a sketch and find the two readings that are cutoff values separating the rejected thermometers. So 2.2%. So again we can sketch normal distribution to see what's going on. And now 2.2% of thermometers show higher readings. Okay, so this probability here is 2.2%, which is also, we can write it as 0.022. all right, so probability of getting that the randomly chosen thermometer shows too high is 0.022. And also another 2.2% show too low. Something's wrong. So another 2.2% shows it's too low. So this area below some value here is also 0.022. all right, so 2.2% of thermometers fall in this region, and another 2.2% fall in this region. And the question is, what are these critical values, cutoff values, that determine whether we treat reading as good or bad, so whether it's too high or not, and whether it's too low or not. Okay, so if you try to use norm-dist function, it's not going to work, because norm-dist function, when you give z-score, it tells you what this probability is, but we need a reverse process. So what should be this number here, so that the cumulative probability up to that number is 0.022. Okay, so it's a kind of inverse process of what we were doing so far, and we will be using the function in Excel norm.inv. So it gives you an inverse cumulative function, so that gives you the z-scores that correspond to that probability. all right, and we also need the other one here. So what should be this value here, so that above that value you get only 2.2% or 0.022 thermometers. Okay, but because this is standard normal distribution, so that's symmetric, about 0. And since we have too high being 2.2 and too low being 2.2, that means 2.2%. That means because of the symmetry of these areas and the symmetry of the curve, these two question marks should be replaced by some numbers which are opposite of each other. Okay, so that the question is, what are these two numbers? Well, it suffices to find one of them. Once you find one, the other one is the opposite of the other of that one. So let's find this one because it's easier. That's cumulative. So we use norm, as I said, norm.inv. So inverse normal probability. So it gives, for given probability, in our case that's 0.022, it gives us z-scores. But of course the mean, since this is not a standard normal, the mean is 0, the standard deviation is 1, and there is no fourth argument, so just this, so close it, and so we get negative 2.01409. So this question mark is, or I should do this, is negative 2 point, what did I just say? Here, negative 2.01409. And therefore the other cutoff value is 2.01409. okay, and it also says in the problem, so okay, so we actually first need to determine what region corresponds to what picture corresponds to this problem. So what region describes the probability of bad thermometers? So that means too high or too low. Well, since it's too high and too low, so it's a two-sided. So this is the region of bad thermometers showing too high. So that's actually the probability of thermometer showing too high value, too high temperature, too high reading. And this is the probability of thermometer showing too low. So that this is the problem. This is the picture that we are looking for. So that's B. And the cutoff values are, so let us find the cutoff values. So let us find these. So we actually found them, all right, but we are not done. It says use a comma to separate the answers. So of course, since we have two cutoff values, so we need to put both of them and separate with comma. But it also says round to 2 decimal places. So how do we round to 2 decimal places? So this is approximately 2.01, and similarly this one is negative 2.01. okay, so the answers are negative 2.01 and 2.01. comma 2.01, and that's the answer. So that's what I wanted to show you from section 6.2.